Welcome to Jeremy's IT Lab. This is a complete course for the CCNP ENCOR Enterprise Core exam. This course will cover all topics you need to know to pass the ENCOR exam. In this video, we will look at the debug command, a very useful tool both for troubleshooting issues as well as for learning about various protocols and features. The debug command can display messages to provide information about various events on the network, and we'll look at some ways it can be used in this video, as well as throughout the rest of the course. Here's what we'll cover. First, I'll give a general introduction to debugs. Then, we'll look at conditional debugs, which allow you to filter what output is displayed. This is useful because enabling debugs can cause a lot of output, so it can be difficult to find the information you're actually looking for. Then, I'll give an example of using debugs to verify OSPF neighbor adjacencies. And also one more example, the debug IP packet command. There are countless debug commands, so instead of trying to cover a bunch of them in this video, we'll look at them as appropriate throughout the course. We've already used debugs a few times, such as in the MSS and ICMP videos. I also recommend experimenting with debugs as you do practice labs. This video will serve as a general introduction to debugs, but to really get familiar with them, you have to practice using them. At the end of the video, we'll also look at a bonus question from Boson Software's ExSim for ENCOR, so make sure to watch until the end. Let's get started. Debug is a Cisco iOS command that causes the router or switch to generate syslog messages in response to various network events. There are a lot of different debug commands you can use. Debug, followed by a question mark in iOS V, gives 243 options for debug commands, and most of those have various subcommands to specify what kind of debug you want to activate. The debug messages are displayed or sent to wherever debug level logging is enabled. That's syslog level 7. You can use show logging to confirm. And remember that if connecting via the VTY lines, for example with SSH, you will need to use the terminal monitor command to view them. Otherwise, they will not be displayed. Here, I used show logging, and you can see the defaults for this iOS V router. Level debugging is enabled for the console, monitor, and buffer. We'll review syslog specifics more in another video, but just keep in mind you need level debugging enabled to see debug messages. As an example, I used the debug adjacency command on R1. This command displays debug messages regarding the Ceph adjacency table. I then used the clear adjacency command, and as you can see, various debug messages were displayed. Note that you can enable multiple debugs at once. If you want to view which debugs are active, you can use the show debug command. If you want to disable the debug, use undebug all. Or you can disable the specific debug. For example, if you have multiple debugs enabled and want to disable only the adjacency debug, you could use undebug adjacency. After disabling the debug, clearing the adjacency table does not result in any debug messages being displayed. Debugs are useful, but you should not use them carelessly on devices in a real network. Cisco recommends being careful about using debugs. Here's a quote. Use debug commands with caution. In general, it is recommended that these commands only be used under the direction of your router technical support representative when troubleshooting specific problems. Enabling debugging can disrupt operation of the router when internetworks are experiencing high load conditions. Hence, if logging is enabled, the access server can intermittently freeze as soon as the console port gets overloaded with log messages. Before debugging, look at your CPU load with the show processes CPU command. Verify that you have ample CPU available before you begin the debugs. To summarize, debugs can increase the load on a device's CPU, so be careful about using them. And a few more points. Devices prioritize console output ahead of other functions, so too much debug output to the console can cause the device to hang. Keep in mind that logging messages, including debugs, are sent to the console line by default, even if you are connected to a VTY line. So you might not be using the console, but the messages are still sent to the console line. So, Cisco recommends disabling console logging with the no logging console command and only enabling it when needed. Finally, always remember to disable debugs when you're done with undebug all, or no debug all works too. Anyway, the point is that you should be careful about how you use debugs if a device is being used in a real network. You don't have to be paranoid, but just be aware that depending on the current load of the device's CPU and the type of debug command being used, it can overload the CPU. To reduce the number of messages produced by a debug, you can do a conditional debug. This reduces the load on the router, and reducing the number of messages to only the ones you need also makes it easier to read the output. You can specify one or more conditions for debugs, and only debug messages that meet one or more of the criteria will be displayed. If you set multiple conditions, not all of them have to be met, only one. Let's see how to limit debugs by interface. First, I use the debug IP packet command. We'll look at this command a bit more later, but it displays messages about packets that are process switched by the router. Then I set a condition, debug condition interface G00. So only packets sent or received on G00 should be displayed. I pinged 192.168.12.1, R1, and then a bunch of debug messages are displayed. This is why I specified repeat 1 in the ping. Debug IP packet can show a lot of messages. However, when I ping R3 at 192.168.23.3, there are no debug messages. That's because I set the interface G00 condition above. Next, I use the command debug interface G01, and it says condition 2 set. This has the same effect as debug condition interface G01. When specifying an interface as the debug condition, you can use either command, it doesn't matter. So I pinged R3 again from R2. And this time, debug messages were displayed, because I added the G01 condition. Remember, packets only have to match one of the debug conditions. They don't have to match all of them. Now let's look at how to remove debug conditions. The undebug all command disables debugs, but does not remove the debug conditions. That means the conditions will be applied to future debugs, unless you remove the conditions separately. To do so, use the undebug condition all or no debug condition all command. You can also specify specific conditions instead of all, either the condition number or name. For example, undebug condition 1 or undebug condition interface G00. So let's see how this works. Show debugging displays the currently activated debugs as well as the conditions. I use the undebug all command to disable the debug. However, as you can see, the conditions remain. I then use undebug condition all, and after a warning, it removes the two conditions. So, we looked at how to configure a debug condition based on interface, to only display debug messages relevant to a certain interface. We also looked at how to remove debug conditions. Here are the different debug conditions available in iOS V. I recommend experimenting in a lab to get familiar with some others. Let's look at an example of how debugs can be useful by debugging an OSPF adjacency issue. You notice the following syslog messages repeating endlessly on R1. So it's trying to become OSPF neighbors with R2, but it keeps moving between xstart and down. Clearly, something's not working. You can use debug IP OSPF ADJ, that's adjacency, to identify the issue. Here's the output after activating OSPF adjacency debugging. Notice the parts I've highlighted. R1 is saying that the neighbor, R2, has a larger interface MTU. It also states R2's MTU, 1550. R1's is currently the default of 1500, so that's the problem. If two routers have an IP MTU mismatch, they won't be able to reach the full state. So, I adjusted the IP MTU of R2's G00 interface. Then, R1 and R2 were able to reach the full state. Notice in the output you can see xstart, xchange, loading, and full. In the OSPF section of the course, we'll look at this and other OSPF debugs in more detail. For now, I just wanted to show how debugs can be useful in troubleshooting, as well as for studying purposes. If you're learning about the OSPF neighbor adjacency process, examining debugs can be very useful, especially in combination with analyzing packet captures. Finally, we'll look at one more example of a debug command, debug IP packet. The debug IP packet command displays messages about packets that are process switched by the router. It can produce a lot of output, so it should be used with care. For example, you can do a conditional debug to limit the amount of output. You can also add the detail keyword to get even more information about each packet that is received and sent. Let's see how it works. On R2, I did debug IP packet. Then on R1, I sent one ICMP echo request to R2 and one to R3. Let's check the debug output on R2. As I've highlighted, R2 only shows debug output for the ICMP echo request R1 sent to R2, not the one sent to R3. Notice that multiple messages are shown, a few for when R2 receives the request, and a few for when R2 sends the reply. This is for one ping. If there's a lot more traffic, the amount of debug output can be overwhelming. So, as I said, R2 displays debug messages for the ping it received from R1, but not for the ping from R1 to R3. And this is because R2 uses Ceph. Packets to and from R2 itself are process switched, so they appear in the debug output. However, R2 uses Ceph to forward messages between R1 and R3, so they don't appear in the debug output. So I used debug IP packet detail to see more information in the debug, and then I also disabled Ceph on R2. Don't disable Ceph on a real network. I'm just doing this to demonstrate the debug IP packet command, but if you do this on a real router that is forwarding a lot of traffic, you can easily overload its CPU. Then, I sent another echo request from R1 to R3. This time, R2 does display the debug output for the exchange between R1 and R3. Because Ceph is disabled, it process switches the packets. Notice that with debug IP packet detail, it shows information like the ICMP type and code. Type 8 for echo request, and type 0 for echo reply. Now, as I said before, debug IP packet can give a lot of output, which can overload the router and also be hard to look through. So it's best to limit the output. One way is to do a conditional debug, as shown before, but another method is to use an ACL in combination with debug IP packet. Let's see how to do that. I configure extended ACL 101 with a single entry. Permit ICMP host 192.168.12.1, that's R1, host 192.168.23.3, that's R3. I then did debug IP packet detail 101. So, R2 should only show debug output for ICMP packets from R1 to R3, not for packets from R3 to R1 or between R1 and R2. To test, I once again sent one echo request from R1 to R2 and from R1 to R3. Here is the debug output on R2. Due to the ACL permitting only ICMP traffic from R1 to R3, only the ICMP echo request from R1 to R3 is shown in the debug output. R2 shows a couple messages when it receives the packet from R1, and a couple messages when it forwards the packet to R3. That's it. Note that other traffic is not denied, it is just not shown in the debug output. The ACL is used to identify traffic for the debug, not to control traffic. ACLs aren't used only to permit or deny traffic. They are often used to identify traffic for other purposes, as shown here. Here's what we covered in this video. I introduced the debug command and how to do a conditional debug. I then gave two examples of debugs, debugging OSPF adjacencies and the debug IP packet command. We already used debugs a few times in this course, and we will use them many more times in future videos. I recommend practicing using debugs in labs. You need to understand debugs for the ENCOR exam, and they are a useful tool for studying and troubleshooting networks. Now let's move on to the quiz to test your understanding. And make sure to watch until the end of the quiz for a bonus practice question from Boson Software's ExSim, the best practice exams for ENCOR. Okay, here's quiz question 1. You issue the following command on R1. The command is debug condition interface G00. Which of the following commands can be used to remove this condition? Select all correct answers. Pause the video now to think about your answers. Okay, the answers are A, B, and E. You can use undebug condition all or no debug condition all to remove all conditions, or no debug condition 1 to remove the specific condition. Undebug all and no debug all disable all debugs, but do not remove debug conditions, so C and D are incorrect. Okay, let's go to question 2. Which of the following statements about conditional debugs is correct? Pause the video now to think about the answer. Okay, the answer is B. One or more conditions must be met for a debug message to be displayed. If you set multiple debug conditions, only one of those conditions has to be met for a debug message to be displayed. There's no need to match all of the conditions. Okay, let's go to question 3. You issue the following commands on R1. Those are ipsef, debug IP packet, and ping 8.8.8.8. Which of the following statements are true? Select 2. Pause the video now to think about the answers. Okay, the answers are B and D. The ping between R1 and 8.8.8.8 will display debug messages, because even with Ceph enabled, R1 will still process switch some packets. For example, packets sent to and from R1 itself. However, when forwarding packets between other hosts, it will not process switch them, unless it is a special case like a packet using IP options. Okay, that's all for the quiz. Now let's move on to a practice question from Boson ExSim. Okay, here's today's Boson ExSim practice question. You configure the debug condition interface Ethernet 10 command on a Cisco router named R1 and receive the following output. The output is condition 2 set. Next, you issue the debug IP EIGRP neighbor command on R1. Which of the following best describes this configuration? Select the best answer. Okay, pause the video now to think about the answer. And let's check. First, how about A? Only debug messages that traverse the Ethernet 10 interface and are designated as severity level 2 will be displayed. That is not correct. Nowhere does it state severity level 2 or above. It says condition 2 set, but that just means it's the second debug condition. How about B? Only debug messages that match the Ethernet 10 interface will be displayed. Okay, that seems correct, but notice that it says condition 2 set. That means there is also a condition 1 here, so B is also incorrect. Next, C. Only debug messages that match the Ethernet 10 condition or one other condition will be displayed. This should be the correct answer. Ethernet 10 is condition 2, so there is also one more condition as well before it. And option D is incorrect. It says only debug messages of severity level 2 will be displayed. But as I mentioned before, this condition 2 set output doesn't mean severity level 2. It means debug condition 2. There is also a debug condition 1 before it. So C is the correct answer. I'll click on Show Answer. Here is Boson's explanation. I recommend pausing the video to read it. ExSim has very useful explanations about why the correct answer is correct and the incorrect ones are incorrect. There is one thing I want to point out near the top. It says debug conditions are not cumulative. Therefore, a debug message can match one or more conditions in order to be displayed by the router. So if you configure two conditions, a message only has to match one condition to be displayed. Remember that point. Okay, that was a quick look at Boson Software's ExSim for ENCOR. If you're preparing for the ENCOR exam, I highly recommend using ExSim to identify and strengthen your weak points before attempting the real exam. Before finishing this video, let me thank my JCNP level channel members. To become a member, please click the Join button under the video. Thanks to Yonatan Makara, Velvet Jacob, George Streeter, Funny Dart, Nasir Chowdhury, Devin Suku, Gustavo BR, Gerard Baker, Marcel Lord, Pavel M, Mr. Erlison, Dragos Hirnea, Zakib Shah, Mayor Salman, Mazen Anderson, Vitaus194, Gina Lindley, Mark Jackson, Bold1C1U, Michael Carroll, Gerald Guillaume, Gabriel Braga, Hector Hernandez, Maratuba, Roji Kuriakos, Arpad Konives, 5 Feet, Owad, Tricky Mickey 123456, Daniel Brown, Scott Thompson, Jose Alvarez, Kevin Hayes, Hussein Yavuz, Samuel Tavares, Mustafa Irsoy, Dear Diso, Nasser Zahar, Brian Grant, Alexandru Badic, Georgi Gemejev, Dibya Swain, Arlen Plagaria, Adelson Pereira, Farad69, Lucian Stoichitoyu, Madmark 50484, Sean Powell, Alexandru Stratan, Hiago Bicalho, Abdo Zizo, Piotr Kaimov, Abubakar Berry, Jeremy, you are really, really great. Thank you for the name, by the way. Kurt Nell, Preeti Dongave, Omid Farakesh, Steve Cox, and Joe Black. Sorry if I pronounced your name incorrectly, but thank you so much for your support. Thanks to you and my other supporters, I am able to make these videos and release them for free on YouTube, so I really appreciate the support. Another great way to support the channel is to like the video, leave a comment, subscribe, and most importantly, share this video with others. So, if this video was helpful, I'd appreciate it if you did any of those. Thanks for watching.